What's this computer? Zoom. On that. So I've got the pause button showing. That means it must be recording. Now it says recording at the top left. Superb. Yeah. So what will the plan today really is just to have a look at some microcontrollers, and then I've got a little bit of code and a couple of, like, I guess, demonstrations and stuff that we can go through. I think, as everybody who's dabbled with these things knows, that this is a 12-month course at least to try and become experts in these kind of things. So all we're really going to do today is touch the surface. But I remember when I first started with this, what I wanted to do is just somebody talk me through an example so I could get my head around how it actually worked. There's loads of resources on the internet, etc., where you can kind of look at all the different commands and what everything does in detail. But it's just that initial kind of getting started. So I thought we'd go through that. Right, I'll just throw some stuff up first of all. Share screen. That one. There we go. Hopefully you can kind of see I've just put some stuff together. I mean, these sessions do start right from the kind of very basics, very beginnings. The other thing is, if you want to ask questions, just fire away, because we've got a kind of very loose agenda that we'll go through. We've got some guys on that are by no means beginners, so the whole thing is we just collectively work through these things and chat through them. So the first thing what we're going to look at is the microcontrollers, and they're different than small computers. I think this is one of the things that I often get asked when people first start. It's one of the things that confused me when I first started. It's things like Raspberry Pis and other computer-based devices are very different than what we use, which is specifically designed as I/O controllers. So what they do is they grab information, and there's a couple of things up there that tell you what an Arduino is, what an ESP is. But what they're doing is really looking to gather some information or gather some input from the world, do something processing with it, and then output it. So it's bare bones. It can be automating flashing lights on a prop. It can be playing sounds. It can be starting to read some Bluetooth signals that are coming from a phone or a controller and converting it into motion. So, and the Arduinos are superb for this, because they're very low power and they're actually designed to that. So all of that control, all of that input and output kind of sits on the board itself. You can do this with things like Raspberry Pis and some of the more advanced ones. And if you want to get into fully autonomous droids that will go around and can recognize what a human being is, point a gun at them and shoot them, and the full autonomous thing, then we start to look at some of the more advanced stuff. But for the vast majority of what we build, these little boards are superb. The other thing with them is they're just crazily cheap, and they're getting cheaper and cheaper. The one that I'm playing with at the moment is this ESP32, and what's happened, I think, in the community is we've got really used to the Arduino, and it's solid, it's reliable, it works, it's easy to understand. Steve's got a ESP32 there connected up. It's also very old technology, really old. It's a single thread processor. It's 8-bit, so it's superb for what it does, but it has got its limitations. What's been interesting is and I've only had a couple of weeks playing with the ESP, but the ESP is almost a modern day version of the Arduino. So it's got a load of extra memory, it's got a load of extra processing power. It's a fast little device. And the other thing is it's got built-in Bluetooth, it's got built-in Wi-Fi. And I think I paid about a $5 for it, to be honest. So these things are just crazily cheap as well. So just to quickly go through the difference between them. There's if you look at the architecture on the on the SP32, it's massive and very complex. But just to kind of give you a real top level view of what we're looking at, there's one in the middle called an ESP8266, which you can kind of ignore because it's been superseded by the SP32. We use the Arduino Unos on the right hand side, and you can see there that they're single core 8-bit architecture. The ESP32s are 32-bit architecture. They're 10 times faster from the clock speed perspective. They've got built-in Wi-Fi, built-in Bluetooth, and they do support up to 16 meg of memory, whereas the Arduino is up to 32K. So when you look at the numbers and the specs, these ESP ones are outstanding. I guess at the moment they're not quite as well supported as the Arduino family, and therefore that's where it's reliable and it works, and we've got a lot of standard builds that work very well on the Arduino, but I can rapidly see the new stuff, the SP32, kind of kicking in and starting to take off. You've got 36 pins, input outputs. You've got a whole bunch of what are called buses, which is the way that it communicates with other devices. You've also got a lot more analog pins, and you've got the ESP32 actually has what's called a DAC on it, which is a digital to analog converter, which means in theory it can play sounds or sound effects on its own without the need for an external player. I've not played around with that. It is a little bit more complex because what you've got to do is create a WAV file. You have to effectively convert the file into a hex file, and you have to put it in the code, from what I can see. So it is quite complex to get it on there, but theoretically it can actually do that. And there's lots of. I mean, the DF player, which is one that we use a lot on the smaller ones, is a crazily cheap small device with a built-in amplifier. So again, it kind of it certainly does the job, and it's probably a better solution than using the onboard one. But what you're looking at really is a whole bunch of new features that sit on there. The other advantage you've got with the ESP32 and the Arduino is they both use the same programming environment and language. They can support other languages, but they if you're familiar in any way, shape, or form with the Arduino Uno or the Arduino language, you can click very easily over to the ESP. Does all that make sense? Yeah, cool. Just on these two boards, and we'll get into a bit more of the practical stuff shortly. But is there any questions on there before I move on a little bit? No. Cool. No. Okay. So what I thought we would do then is just have a quick look again, starting very much at the beginning of the basics for people. What we use is the Arduino is the I/O device that we've just talked through, and what we use something called the Integrated Development Environment, or IDE, which lets us build up the code that's in there. And as I said, we're not going to be able to go through all the code and trying to get a understanding of what every command does. But if you've programmed previously in BASIC, or you've done, even back on the old Sinclair Spectrum days or whatever, the code is actually quite familiar when you start to look at how the logic stacks up. And it's all inputted through this this environment. And what all you really do is you either write the code in there. What the vast majority of people do is they steal bits of code from all the other sketches and cobble them together and get it to do something. And once you start to look at code and understand how it works, you can start to do that yourself. Once you've got the code in there and you're happy that it works, you can then upload that through to your Arduino. I'm just going to stop screen sharing at the moment. There we go. And what I'll do is I'll just jump into the Arduino interface, and then you can have a little look at what that actually looks like. There we go. Don't know if you can see that in a little window. Yeah, cool. So this is the this is the interface that we use. This is the stock software that comes with Arduino, the environment, and this has already got a load of code in here. Once you've gone through the basic steps of grabbing yourself a Nano or an ESP or whichever board you want to get to, and you load this software up, the best place to start is some of the example sketches. So within here, if you click at File and Example, in here are literally kind of hundreds of bits of, oops, let me click on link there, hundreds of bits of code, File, Examples, there's hundreds of bits of code in here, which all really are example code that you can use to learn. So literally you can start at 0, 1, the basics, and there's some sketches on there that do a very basic analog read, the blink. So if you remember the old Hello World computer code that you used to have that printed Hello World, blink is the Arduino standard. And I'll just open, let me just open blink. I must remember that when you open a new window, I have to reshare the window that I've just opened, otherwise I'll be talking about something and you won't actually see it. Share, there we go. So this is probably the first one that you look at, and I'll talk you through how the code is set up. So there's three main areas with Arduino. There's this first bit, and the three areas are split up by these void statements. So you've got a void setup, you've got a void loop, and then you've got this bit that sits before everything. The way to think of these is the three little environments. So everything that sits before this is what's called is kind of like a global environment. So anything that you put in there is accessible by all of the. So if you set a variable up in there or anything like that, it's accessible anywhere inside the programs. These little voids are like little subroutines. They start with, I don't know if you can see that little symbol, the little curly brackets, and they end with the curly brackets, and everything in there is classed as the setup. And then the second void you've got there is loop, and everything that's in there is loop. So the Arduino code is split into three areas, which is global, a setup, and a loop. And what happens is the global runs first, then the setup runs, and that's a bit like when your PC boots up. It's literally just firing up all of the drivers and setting things up. And then effectively the loop is where the main code happens. And the Arduino, again, is really simple. All it really does is it does one statement, one statement, one statement, one statement, and then back to the beginning. And as long as you leave it powered up, it'll just keep running that code again and again and again. So that's your three areas. And so this blink that we've just looked at, all this is really doing is it's first of all in setup, is it's setting up and it's something called pin mode, and there's on all the Arduinos there's a little built-in LED, so you've not even got to buy an LED to plug into them. You've got a built-in light that's on the outside on the board that you can flash if you want to. So it's saying the built-in LED is an output pin, and then all it's really doing there is digital write LED built-in high. So what it's doing is turning that LED on. It's got a delay of 1000, which is 1000 milliseconds, which is 1 second. Digital write LED built in low, switch it off, and then delay it a second. So it is that. All that really does is it flashes the internal LED on and off every second. And as I said, this area here, if you're like me, where I tend to just learn by watching other people do stuff, this area is absolute gold dust, and I think it's often overlooked by people when they first start with these things, because you can start off with the basics. So there's things like the flashing LED that we've just seen, how to read different areas, and then it starts to get more and more complex. So you can get right down to keyboard and mouse control, how we do things with things like strings. There's all sorts of stuff in there. So really, really useful area if you ever just want to play around and start to learn. And then as you scroll down, there's lots of other examples, and the way that the Arduino or the way that the environment works is it gives you all of the default commands, and then there's things called libraries. And what the libraries do is they're a bit like drivers, so they load onto the Arduino and they give you additional and more functionality. And every time you add a library, you tend to get an example. So if you are loading a library for a Sabertooth 32 speed controller, for example, there will be examples that come with that library. If you load a library for a Bluetooth, there'll be examples for that Bluetooth module. So each of the libraries have got examples, and all the examples tend to be in the same format. And what they have is a lot of what's called commenting, which is these little descriptive pieces of text. So the idea is that you can load an example, read through, work out how it works, and get going that way. That all makes sense so far? Thumbs up, brilliant. Any questions at this stage? No. Comments?
Hey, I got one for you, Mr. Badley.
Go for it.
So my question is this: in the brackets, you can put instructions or directions of what that function is and it not affect the program?
That's yes. So the little two forward slashes, which you can see there.
Yep.
That just says ignore all this text that's after it. So what it'll do if I put my line here and I put I don't know, I'll just make one up, serial print command. I could say, for example, I've added a line, so you can see now that's orange and it's blue, which means that is actually a command. So that's doing something. That's gonna affect the code. If I put those two little brackets before it,
It turns it off.
It switches it off. It now becomes a comment.
Okay.
So in here I can type whatever. Does that make sense?
Oh, yep, makes sense.
Now, where that's really useful is when you are playing around with code, you can actually use that to disable commands without removing them.
Okay.
So, for example, this has got a 1 second delay between it coming on and off. If I put those two in, it'll now not delay between those, which means effectively the LED will be off all the time. But you can actually disable commands by just doing those little things.
Okay, thank you.
Yeah. The other command that you'll see there is a /* and then a */. And what that does is rather than having to type one of them on every single line, if you want to put War and Peace and descriptions, you can say, right, start comments and then stop comments. So that then does that to that whole block of text. Okay.
Thank you.
Cool. So so hopefully the way that code works, kind of makes sense. But honestly, just have a play around in there, because there's lots and lots and lots of different things that you can learn. What we often do, what I did when I first started, was things like I'd build the Pad 1 through 60 that controls R2, and I wouldn't even look in the instructions in here to see some of the Sabertooth. So what I'm actually doing is I'm kind of hopefully sticking all of the wires and cables together. I'm hopefully loading the code correctly. I'm crossing my fingers, and if everything works, it's fantastic. But what I'm not doing is learning about the devices. So when things don't go right, then it becomes a lot harder to fault find. So what you can do is just keep playing around with those examples and learn, and sort of have fun and enjoy it as you kind of go through. Okay, let me have a look now. See where we are. So what I'll do now is I'll just pop into. So I'm not going to go right through the basics. What I'll do is I'm going to pop into some little Bluetooth examples, which is kind of fairly, I wouldn't say advanced code, but it's sort of 2 steps forward. But we can start to see some of the practical examples of what we're doing, if that makes sense. Let me just share my screen again. So, and again, if you've got questions, just ask as we go through. So what I'm gonna do is I'm gonna jump. Well, I'm not gonna jump in at the deep end, but there's a little phone app. One of the things that's really cool to play with on these, and it's not too difficult at all to get started, is trying Bluetooth control through your mobile phone. On the little mouse droids that we put together, these little fellows, if you can see that on the video. What I've done is I've used Dabble as a way of controlling those, and so Dabble is it's a phone app. It's available on all the usual kind of the Apple Store and the Google Play, Android, and all the different sort of platforms. And all you really need is this screenshot is how you connect the Bluetooth receiver to an Arduino Nano. But all you've got there is you've got a Bluetooth board and you've got an Arduino. And if we look at how it's connected, we've got 5 volts and ground, which is powering that external board, and then there's TX and RX. So this is called serial data. So it's just a way of swapping data. So literally, we've got the TX connected to pin 2, and we've got the RX connected to pin 3. And what that means is literally you've got a Bluetooth board connected to the Arduino. And on the little boards I put together for the mouse droids, it's actually those connections are already in there. So you plug there's a little Bluetooth board that you can probably see on the back. And then you've got a Nano that plugs on there, but all it's really doing is making those connections that sit on there. So what I'll do is I'm now going to pull. I won't show that on video, it's quite boring. But all I'm really going to do is just plug the USB connection into the Nano, get a couple of magic lights going, and there we are. So what I've done is I've just connected up the Nano. Let me just fire into and share. I'm flicking between screen shares here. Let me just share Gamepad. There we go. Okay. So just to jump into that, just a practical example. So all I've got at the moment, I've got the Arduino Nano connected to that Bluetooth controller that you saw on the previous one. It's literally 4 wires. In this case, it's actually on the board, but it's the same thing. And I've gone file examples. Oops. Wasn't it? My PC, everything. The hell's that on? You still there?
Yeah.
Are we still there?
I see you.
Good. My mouse pointer's just stopped. Let me just unplug. PC's playing up. Interesting. Control not play. Right. I think it's come back now. I think it's really. Is sound coming through all the time?
Yeah.
You can hear me okay. Cool. Oh. What the? Bear with me. What the hell's that? Right. It's had a little wobble there. I'm back now, moving. I'm assuming nothing happened then for you guys. It was just me that all went into a bit of a thrombin. Right, I can fire that up. Plug that back in.
We did get all your credit card number and PIN numbers as well.
Excellent. Well, that's fine. Just knock yourself out. There's not much on there. Right. So, okay. So this is sorry about that. A complete thing. This is an example from Dabble. So basically all you do is download the app to your phone. You connect the Bluetooth up, as we said, And then if you go into file and examples, there's some of these examples are in here. So at the moment, I've got the Arduino Nano selected as the board. What you have to do in the IDE in this environment is you make sure that you've got the right board selected. The Nano does have a couple of different processors that you can select. You can do these by trial and error, to be honest, to get it up and running and working. And then when you plug any of the devices up via a USB connector, it creates a virtual serial port. So this one's on COM3. So I plugged it in, it's up and running and working. To get the code onto the Nano, all you do is click on the sketch and upload, which we'll just click on that now. And it goes through 2 stages. So the first stage is it compiles the sketch, so it makes it into something that works specifically for that device or for the Nano. And then once it's finished compiling, what it will then do is it'll go into the uploading. And when the uploading happens, what you should see is the TX and the RX lights flash very, very quickly. And then at the end of it, it comes up with done uploading. In my experience, and again, anybody feel free to jump in, these things are pretty bomb-proof, really, when you're uploading. So you can't screw a Nano up by half uploading code or anything like that. They are pretty solid. Obviously, if you get voltages connected wrong, they can let out magic blue smoke and stop working. But from a basic programming and setting up perspective, they go they're really simple. So all that's done now is that's uploaded the code onto the actual board. What I'll do is I'll just quickly step through the code, because the code's really quite simple. This is just the example. The example I've loaded is the Gamepad, and the reason I've loaded those, and what I'll do is let me just flip the camera over and I'll show you what the Dabble app's like as well. So stop share. Let me flip the camera to this one. There we go. So hopefully you can see that now. So yeah, I'll just quickly show where's dive. So when you fire Dabble up, get it the right way around. It comes with a couple of different devices, so you can choose. Let's just fire back there. Yeah, so when you first fire the app up, it comes up with different things that you can actually get on the app. So I like playing around with the Gamepad. It has a standard Gamepad that's just built into the app. If you want, and you click on that top button there, you can then change that to joystick mode. Anybody who's built with a mouse droid, this will be very familiar. And then it gives you an analog controller. It gives you some buttons to press, and you've effectively got a little gamepad. It's really, really simple, and it's really handy to play around with. And so, probably your screen connectors in. I'm putting anything silly. Okay. So I've just uploaded the code to that Nano. And what you've got on the app there is you've got a little button that looks like a plug that's being connected. You press the plug button. It gives you a list of Bluetooth devices. You select DSD Tech, which is what comes up with, which is what comes up on the actual Dabble software or the Bluetooth. It's what the Bluetooth calls itself, and that plug is now connected. And that's literally it. It's that. There's no difficult configuration. There's no programming. All I've done is load the example sketch, hit the connect button, and this joystick is now connected to that board. Does that make sense?
Yeah.
Okay. Now if I share screen, I'll just go back into the Gamepad app now. So what the code is doing, the Dabble code, and again, this is just a default sketch that's an example, is it's got some stuff at the beginning. So what it's doing there is it's loading the Dabble library. So that's the driver. It's starting serial. Now, This command serial.begin is really important because when you go into serial monitor, because serial monitor is a way you can see what's going out there, that'll tell you your baud rate, and everybody has different preferences. This one's quite unusual in that it's 250,000 the baud rate for this one. But when we go into serial monitor, that's quite important. Otherwise, you'll just get gobbledygook out, which I'll talk through. And then it literally just kicks dabble off. Once it's kicking dabble off, it then goes into the loop, and all the loop really does is it first of all processes it refreshes the data from the phone, and then there's a bunch of these what are called serial prints, and anything that's serial printed is what you can see in the serial monitor. I'll go into the serial monitor in a sec, but what it's going to do is it's going to print key pressed in plain English, and then it's got a little statement to say, is the up button pressed, in which case it's going to serial print up. Is the down button pressed, in which case it's going to serial print down. Now, when I said before that what you can do is steal other people's code, if you wanted to use Dabble to control a motor, or you wanted Dabble to control lights, what you can do is you can say, if the gamepad up is pressed, you can add your extra command in there that will move a servo or will move a motor. So you can literally just inject your specific line there that says, right, go forward to such a pin or whatever it is for that specific device. So the example's already there. So what this is really doing is it's just checking each of the keys. If they're pressed, it's just going to print that it's been pressed. And then at the bottom, it's got some more commands that actually start to show you where that analog joystick and the data that comes out of that. So the code is really simple on the Dabble. If you click onto tools, where are we? Just make sure I've got COM port correctly selected. And we go into serial monitor. That opens another window. So let me just, again, fell foul of this before that with Zoom. So what you've got to do is kind of swap the windows over. So stop sharing and reshare. Serial monitor, which is that one there. Share. Okay. So I assume everybody can see that. So literally, this is now the output. This is what's coming out of that Arduino. When I said before about making sure that your baud rate is correct, in the serial monitor on the bottom right hand corner there, you can see it's got 250,000 baud. If that's at 1120, what you do is you get gobbledygook out. Okay, so that has to match what's in. If you're getting rubbish that makes no sense, it's generally because you've got your baud rate set up incorrect. And all that's really doing is doing the serial print. Now, if you're doing development or you're playing around with your own code, you can use serial print to start to look at what's actually coming out of the code that you're doing. You use it as fault finding. Really, really handy to do. Now, again, if I just put the keypad on there, so if I now press buttons, so I'm just going to press the arrow, the top button, which is triangle. So you can see there it says key press triangle. If I press the bottom button, key pressed cross, circle, square. If I grab hold of this little disc here and move it, you can see the angles change and you can see the radius change. Does that make sense?
Yeah.
So just stepping back now, all we've really done is connected 4 wires between an Arduino and a Bluetooth, loaded an app on the phone and loading an example code. And what you've now got is you've got a joystick that's actually controlling the Arduino. It's not doing anything at the moment, as in it's not the Arduino is not then controlling a servo or a motor. But if you wanted to introduce Bluetooth control into any of your projects, it's very easy. There's lots of these kind of things that kick around that sort of do that. And things like triggering sound effects or switching lights on and off are relatively simple within the Arduino kind of infrastructure. So it's worth just having a little bit of a play around with that. Okay, stop showing that. So if we just But what I'll do now is I'll just go in, I'll just show you kind of from that then where we started to build a little bit out from that, which is the, I'll not got that open. Mouse droid, there it is. Right, small screen. Mouse droid, there we go. Share. Okay. So all I've done now is I've just loaded up the mouse droid code just to show you what I've done with it. So this is the code that that runs the little baby mouse droids on Bluetooth, and you can see right at the top it's actually got all of the text from the Gamepad example. So all I really did was grab the Gamepad example from the example code and added my own bits into it, and I literally cut and pasted it from other areas. So what I did is Dabble was already there. These statements are from the DF player, which is the soundboard that I used. Again, I copied it across. I've set a couple of variables here. These are the speed A and B, which is forward and backward, and then this steer 195 is the default position for the servo, for the steering. And then all I've really done from that is it then kicks off the DF player to make sure that's working. If that's working, it starts to play the first MP3 sound, and that's where you start to get the really annoying mouse sound that goes on playing and makes my wife threaten to throw it out the window. And then we move into void loop, and in the void loop, you can see I've actually left all of the game press. This is straight out of that example code. What I've done is I've removed, by using those two little things that we said before, the serial prints. So we haven't got any of these prints because that just slow it down a little bit. And then towards the bottom where it's getting actually what's coming out from the joystick. Again, they're just the default ones that were already in there. And then the bits that I've added that effectively for the mouse code, that's pretty much it. So all it's really doing is it's saying if D, which is the actual joystick, if it's below minus 0.05, in other words, if we're going backwards, what it's then doing is it's using a command called map. And what I would say is if out of all the commands that you look at, map is absolutely fantastic. It's well worth having a look at. What map does is it takes one number and translates it to another number. And let me explain that a little bit. So what I'm doing with the mouse droid is I've got a joystick, and the joystick's giving me a number between 0 and 6. So 6 is full forward, 0 is center. Now the speed controller, so the motor, how I'm driving the motor, that wants to work somewhere between 0 and 255. So what I've got to do is translate that number 0 to 6 to another number that's 0 to 255. So in other words, if I put 6, which is full ahead, what I actually want it to do is show me 255. If it's 0, so it's stopped, what I actually want it to do is show me 60. So all the map command does is it takes the joystick, which is 0 to 6, and it will now give me speed A, which will give me a number between 60 and 255, depending where that joystick is. Really, really useful command, particularly when we're starting to work with speed controllers. And then what it does on this one is it puts speed B to 0. And the reason for that is speed controller that I use has two pins. One pin drives the motor forward, the other pin drives it back. If I put them both at 100%, it would confuse the hell out of the motor because it couldn't go forward and go back at full speed. So what that does is it says, we know that this is backwards, for example. Therefore, we're now mapping the backward speed and we're putting the forward speed to 0. If we know it's going forward, we're mapping the forward speed and we're putting the back speed to 0. And if it's somewhere in the middle, let's just switch everything off. And then what you've got here is you've got a steer. The steer is doing exactly the same thing, but this time it's mapping -7, which is left, right the way through to 7, which is right, between the numbers 250 and 140, which is the left and right of the actual servo. And then you've got 3 commands here that's just literally sending that out to the speed controllers. So it's sending the we can see from here that one speed controller's on, one of them's on 11, the other one's on 10, and the actual steering servo is on pin 9, and that's pretty much the code. So this is just a sort of example of how we've pulled the standard Arduino examples and kind of literally just injected very simple code in there to get things up and running and working. The difficult thing when you first start is, okay, well, how do I control a servo? How do I control a speed controller? And the answer to that is look in the examples, because in the examples you've got the servo example. There's knob and sweep in there, which is 2 different ways of so all the examples are in there and how you actually control them, and then what you're really doing is mashing code together to make it up and running working. I'll stop talking there for a second. Does that make sense? Any questions on that so far?
Yeah, I've just got a couple questions. The signal that the speed controller needs, you've obviously got 60 to 255.
Yeah.
I presume, is that in that particular speed controller's data sheet as to what signal you need to send it for that particular module or unit to understand? So when you do your mapping, you can then give it the correct numbers that it wants. Yes.
So on the Arduino, the I/O pins, so the pins that write out, there's 2 different types. So there's a digital, which is 0 and 1, so that's on or off, and then there's an analog which allows you to, and it basically does PWM, pulse width modulation. But what it does is it allows it to go from virtually nothing coming out to quite a big wave, if that makes sense.
Yeah.
So the I guess the PWM signal on the pin in Arduino world, 0 is 0 and 255 is max. So that's limited more by the actual Arduino. On the speed controller, what you tend to find with speed controllers is they'll all have different ways of doing things. So on this speed controller that I'm using, you've got, and you can generally see, to be honest, it's not necessarily looking too deeply in the specs. It's just looking at what the inputs are for the board, and what it'll have is it'll have forward PWM and back PWM, and you go, okay, right, now I've got to send 2 signals for a forward and a back. Another speed controller that I use uses 1 speed, which is speed PWM, and then it has a forward and back 1 or 0. So what you actually do is you send the speed on 1 pin, and then if you set the other pin to high, it'll spin it forward, and if you set it to low, it'll spin it back. Yeah. So
it's just
dependent.
Yeah, because I was looking at some stuff, and some modules want a number up to 1023.
Yeah.
And just bits and pieces like that. So it's just establishing where you find that number for what that particular module needs, whether it's 255 or whether it's 1023 or what sort of thing.
Yeah, and what I'm using here is I'm using analog write, which is literally directly controlling the pin on the Arduino. Right. If I was to use a library, so like the servo library, for example, when you open the servo library, you input your output between 0 and 180, which is the angle of the servo, but it'll actually tell you in the library. If you're using a library for a speed controller, like Sabertooth, for example, that may say 0 to 1025. So each library and each hardware will have its own spec. It just requires digging around a little bit to look at those. Yeah. So it is in there in the data somewhere. It's just a case of finding what particular number you what particular number need. And on that mapping, the 60 between 0 and 60, is that your dead zone? Yeah, because what happens with a lot of speed controllers is before they actually start to have enough power to make the motor spin, they'll make that annoying whining noise where it's kicking the coils, but it's not actually turning the motor. So what I can do is I can tweak that dead zone up. You know, if I put that to 254 to 255, it would literally go from 0 to wham. You know, there'd be no ramp up. So again, it's just experimentation really to see where you want to push that up a little bit. And likewise, if you're getting something that's going way too fast, you can pull down that upper limit.
Yeah, and then because the other one's a servo, your 250 is your hard left, your 140 is your hard right, and then the 195, which is at the top, that is your dead center.
That's right. Yeah, absolutely, absolutely. And then you can use the servo library. The servo libraries works better because you know that 0 is 0 degrees, 180 is 180, and 90 is bang in the middle. It's a lot more logical. The reason I don't use servo library on the Nano is it conflicts with the software serial. It's a bit of a nightmare. So I'm putting signals straight out to the PWM, which means I've found those two figures really just by trial and error.
Yeah.
But if for example you slowed this and you found that the steering was reversed, so when you turned left it went right, it's just a matter of swapping those two numbers around and it would reverse the steering.
Yeah. So if you wanted to change that over to a continuous servo, would you then have 90 as your dead center, 180 for one direction, and 0 for your opposite direction, and just swap the 250 to
No, you'd have it as is on there, because if you're using the servo command, if you're using the servo library, that allows you to use the 0 to 180. This is coming straight out of the PWM pin. So effectively 195 is 90. And what you can do with a continuous servo is you have to play around a little bit to find where your dead center is, whereas the servo library does just kick out the 1,500 microseconds, which is what it requires to stop a continuous servo.
Radio.
But this is the reason that this has not got them definitive numbers is because I'm not using any library. I'm just writing straight out to it, which isn't the best thing in the world, but it works.
Yeah. And just while we're still in this bit, going back to the Bluetooth connection.
Yeah.
I see that you'd connected with a HC05. Is that correct? In that example that you flashed up earlier, where you connected the Bluetooth to the Nano.
Yeah, the wiring diagram I got off Dabble's website, which did show a HC05. Yeah.
Yeah. Am I correct that that's happy with Android, but Apple doesn't, or iOS doesn't like that? Is that correct?
That's my experience. Yeah, the HM10s support the BLE Bluetooth stack and the stack that works with the iPhone. So the HM10s I found are more compatible with both devices.
Okay, and that's just connected up the exact same way. TXRX, ground, and VCC.
Yeah, the older HC05s and HC06s are a bit more finicky to get working. I found the HM10s to work a lot more reliably and simpler.
Radio. Yep.
Cool.
No worries. Cool. Thank you.
Any more questions while we're kicking around on that?
Not so much a question, just something that might help people out who are not used to using the Arduino IDE. On the top right-hand corner, you've got it's just gone.
Stop sharing, sorry, Steve.
That's okay. No. On the top right-hand corner, you've got a little magnifying glass that also quickly opens the serial monitor for you. So instead of having to go sketch serial monitor, if you do that, that opens the serial monitor as well.
Yeah. Cool. Anything to add on the motor controls or anything, Steve?
No, not specifically. As you've said, map is an extremely useful one to understand and learn how the map function works. You may end up using that in all sorts of different trains of thought and things, little projects you're doing. The other thing that I've experienced, just to pick up on Thomas's comment, is about continuous servos. They are difficult with a microcontroller to stop moving, if that makes sense. I've had instances. I've one of the props I build is a proton pack, and it's got like a little a pressure gauge sort of thing on it, and we tried using continuous servos, but I had so much difficulty. It would, one day when I told it to stop firing, it would stop. Other days it would start drifting off and jittering around, and it's very difficult with a microcontroller to get them to actually do exactly what you want them to do. if that makes
Yeah.
sense. So,
Yeah.
you know, there's probably better ways of doing it, maybe with a Maestro or a dedicated servo controller as such.
Rightio.
The problem is that the servos work on milliseconds, so you want 1,500 milliseconds puts a waveform, puts the servo dead center. Now the Arduino doesn't work on those kind of milliseconds, and it can be affected by what else it's running. But also it's a fairly sluggish processor, and what you're asking it to do is, you know, every whatever, you know, every 1,000 milliseconds or whatever, or every millisecond to actually time something accurately. So the Arduino does struggle with that. The servo library, if you put the servo library on, what that does is it uses interrupts to do that calculation. So it's a hell of a lot better, and you do get good results. The problem you've got is that what it's actually doing is interrupting every time you want to do that signal that's out there, and it puts a lot of overhead on the overall processor, which is one of the reasons why I wanted to play around with the ESP32, because the ESP32, in my experience, takes it in its stride. It is fantastic for controlling servos.
Rightio.
Okay, so that's just one of the examples on Nano. What I'll do actually is I'll pop these the slides with the links and stuff actually in that little Arduino thing that I put on the patron share. I think there's some useful stuff on there. Let me. So the other one I'll just quickly touch on is the ESP32. So the ESP32, it's not quite as simple, and it's worth persevering, but it's not quite as simple as the Nano. What you've actually got to do is, first of all, add the board to the Arduino. Now there's a little link that I've shown at the bottom. I'm incredibly impatient, so all I do is I Google until I find somebody who can tell me how to do something in 3 steps, rather than having to read the instructions. And this little tutorial I found at the bottom, I found really simple, because it was literally click here, and off you go. And what you do is you go into preferences, you put the web address of where the package is for the ESP32, and then under the board you go into something called Board Manager. You can search the Board Manager for ESP32, and what it does really is it extends the Arduino IDE platform to be able to just instantly kind of start to work with the ESP32. So it's just a little bit of a setup, but it's not arduous or difficult by any stretch of imagination, but it's something you have to do before you can get the damn thing to run. So now just to touch on the ESP32. So just to give you kind of a little bit more of a picture on how I've got these things up and running and working. Because they've got a built-in Bluetooth, you're not connecting anything to it. The Bluetooth's already there, so it's already on board. You've got all the pins that you can connect things to, and effectively on the little bit of an example that I put up that controls the baby R2s, all I've done is connected the serials to 3 pins, and that's pretty much it, and it runs. So if you were trying to fit Bluetooth within one of the baby Astromechs, for example, you could literally pop this wiring loom and connect a bare ESP32 to 3 servos, power the 3 servos, and it would be running. So just to show you what I've connected here, I've got the little 6-volt battery. The 6-volt battery is connected to the 5-volt in, which is at the bottom corner, and ground. This 5-volt, these devices run on 3.3 volts, so it's got its own little voltage regulator in there. It will take between 5 and 10 volts on there to run it, so you can put anything between 5 and 10. I wouldn't recommend you go above 6 volts, because the servos get a bit confused when you start to give them any more power than that. But I run it at 6 volts. Power goes in there and ground. That powers up the actual controller. I'm running the same power to each of the servos on the power and ground pin. You've got to make sure that it's the same ground for everything. So this ground pin off the ESP32 has to be the ground pin on the servos. The power has to be the power. And then literally what I'm doing is taking the signal pin for each of these servos, and I'm connecting them to pin 13, pin 12, and pin 14. And that's all the connection that you make on these things. So you've not got anything that sits in between or any complexity. Is really quite small and quite simple. Now, what I would say on the just on these while we're talking about there, you've got a little button there which you can see which says boot button. I think it's the boot button that you press, isn't it? Look, yeah. So on the ESP32 that I've got, where you would normally click on upload the code onto the Nano, the ESP have one extra step, which means that boot button has to be pressed before it will accept code. So if you try to load the code as you would do with a Nano, it won't take it. So what you've got to do is load the code, press the boot button, and as long as the boot button's pressed down, it's in that right, give me your code state, and then it receives the code. Now these will allow you also to load the code via Bluetooth, and you can do it over over the network, but you can do it through a standard USB as you would do normally. So what I've done is I've used this kind of. Whoops, just go back. Read this. I've just thrown something together like that. If we look at that, I'll stop sharing. Just yeah. So hopefully you can see the. So that's what this little breadboard is. These are really handy. Instead, when you're playing around with these things, it's called a fun electronics kit, upside down, of course. And you just get a load of bits in there. There's quite a few of these on things like Amazon and whatnot, where you can just get all the stuff. So all I've really got is that circuit diagram that you've shown is on there. They always look more complex when you've got wires coming out, but literally it's just power and connecting the servos to it. So, and then all you've really got to do is just connect the USB, which I'll just fire it in. Show you some of the code on the SP32. Plug it in. There you go. Power this up. There we go. Right. All I've really done now, just connected the serial monitor, the USB connector and that code. So this one is another bit of software that I've been playing with, which is called Dabble. Not Dabble, sorry, Blink. So look, Blink. There we go. Just show you what Blink does. Okay.
That's BLYNK, isn't it, Michael?
BLYNK, yeah. So Blink's a little bit more complex. What it's actually is, it's an application development library that's really simple. So all I've done at the moment is I've dragged a couple of joysticks onto here. One joystick is actually doing well. I said it's a dome, but as you can see, it's actually controlling that little servo there, and then the other one actually is a guide. So, and if I just stop there, I'll just kind of show you what the interface looks like. So each device, this is just a joystick. Each device, what you can do is you can select. They have kind of things they're called virtual pins, but what they are is within software. This says virtual pin 1 has got an X and a Y, and the joystick is going to give me -128 to 127 for the X and -128 to 127. I can change those numbers. So where we looked at before, where we used the map command, I can actually do that within the application. And then I can also then kind of change the virtual pin to another one. So what happens is when the software, what the software does is it reads these virtual pins, so it gets these numbers and it does something with the numbers. So I can set these to whatever I want them to do. And there's lots and lots of different kind of configurations, and you can build your own little platform around these things, and you can start to move the joysticks around. So you can design your own app with your own buttons. So it's like Dabble, but it's a lot more powerful. and then you just connect it to the device, and it gives you, it kind of gives you that interface that works really quite simply. So Blink and the ESP32 is kind of the new toy that I'm playing with, but again, it's worth just having a little bit of a play around with it. And as before, it comes with lots of different options and different bits of examples, so that you can learn how it functions and how it works.
Michael, what was the spelling of that again? The name of the app?
BLYNK. BLYNK. Okay. So I'll just quickly show you how the sketch works in Blink. There's the good documentation on their website, and it's pretty nice once you get it up and running. There's a little bit of a gotcha, which I didn't realise, because it doesn't really. I didn't find it. It told you how to easily. I'll just show you on the app how to easily connect. So I've got everything up and running and working as it said, but I couldn't work out how it connected. And the reason being is that on the Blink app, I don't know if you just bit bright that actually, on the Blink app there's a little symbol at the top, which is a Bluetooth button. So there's as well as the joystick there, you can see that, as well as the joystick little widgets that you can put on there, you put this little Bluetooth button on. And what the Bluetooth button does is when you press it, it takes you into the connect screen. Without that, I couldn't work out how you connect the damn thing to the Bluetooth. It just wouldn't connect. It worked for whatever reason. So with that, all you do then is hit connect. You browse the device as you did do before. They always come up as Blink. You hit connect, and then you connect it in. And then what you can do then is use the code accordingly. So that's just a little bit of a gotcha. But what I'll do is I'll just quickly flick through how this code works. So a lot of this, again, if you go into examples, you've got the default Blink examples. What it's doing in this bit of code is first of all, this is setting all the Blink stuff up, which I just kind of took the default. I've added the Servo library on this because I'm using the ESP32. The ESP32 works beautifully. The Servo library, I can have as many pins as I want. It doesn't conflict with anything, so it's very, very nice and easy to use. So I'm using the Servo library. I've got 3 servos. I'm connecting them to 12, 13, and 14, and I'm calling them Servo 1, 2, and 3. Now the big difference with Blink is under normal circumstances, all your code runs in this bit at the bottom here, which is your loop. So everything that we've seen up to now, we've seen it all the loop running. What Blink does, it does something very clever. We talked about these little virtual pins where it said V1, which was the output of that joystick. And what this code does is it only ever runs the code when something changes. So it's not constantly scanning a keypad to see what's happening. It's waiting until the keypad moves and then it's doing something. So Blink works a little bit different like that. So, and I'll just show you what we've got here. So what I've got here is I've got Blink write V1. And what this is this says that if anything is written to V1, which is that joystick, so if that joystick moves at all, so if I start to move that joystick on the phone, it will run this bit of code, but it will not run anything until I actually do that. And then I've got Blink write V2 here. And this one's really simple. So this is actually the bit that controls the dome. So what this is saying is if V2, if that joystick on that keyboard, on that controller shifts or moves, run this code. And all it's doing is it's grabbing joystick A. I set that from 0 to 180, which is the angle of the servo. And then I've literally put Servo 3 right joystick A. That is the entire programming of the code to move the dome. Because all it's doing then is anytime that V2 changes, what it'll do is it'll write that to that Servo 3. This bit here, this V1 code, which is what's actually controlling the drive, is a lot more complex. But what I did is I found a superb bit of code that does differential steering. So I've nicked somebody else's code and I've put all this code in here. And then what it actually does is at the end of it, it does loads of calculations, but it just writes left and right motor speed to that device. And that's kind of as simple as the blink code is. But Blink's a little bit different in that the loop only actually has the blink that runs in there. It's very, very efficient. And then it runs the other bits when you actually start to move things. So probably I may or may not have lost people on that one, but I just want to just stretch it out a little bit more. And that pretty much is everything I wanted just to cover on this session. Really just dipping into the microcontrollers. I think that the main thing with them is grab one, plug a USB cable in, and just start to have a play around with it. And you know and do have a look at the SP32. As I said, I think I bought. They're about £5 each. They're very, very, very cheap. So you know, if you blow one or two up, it doesn't really matter, does it? At that kind of price, it's worth just having a little bit of play with.
Hey, Michael.
Yeah.
Have you looked at the what do they call it? The PS4 Bluetooth connection for the ESP?
No.
Okay.
No. Have you?
A little bit. Yeah.
Okay.
I mean, I was kind of looking. So I like the ESP because it has better inputs, and just better overall performance. And I was just thinking, I mentioned this on the Facebook thread about how I mean, this could legitimately replace Unos easily, and are a lot more capable. When in a place where you have two Unos, you could replace it with a single ESP32 or even beyond that. So it's and the fact that it's got all the integration, and saw some people who are experimenting actually connecting ESPs to each other, which was really exciting, sending control signals over Bluetooth, so that the only thing technically you might need in a slip connector is power, which is kind of interesting and prone to interference, I'm sure, but still the concept sounds awesome. So I was just curious because I think I actually have to get a new PlayStation controller, try it, but I was just looking at some of the code, and it's very reminiscent of the Xbox 360 setup for Arduino. So like a lot of it, you know, when you start talking about the implementation of it, it seems pretty familiar. So
yeah, if you look at the Pad1 360 setup, which is, you know, I mean, it took the building world by storm, really. That and the Shadow, using the standard sort of Xbox or PS4 controllers, or PS3 controllers, should I say. I mean, it was absolute black magic when I first started. Whereas now, when I'm looking at it, I actually think it's not that difficult code, really. It's fairly simple in the way that it's been coded. So I think, you know, I'm conscious at the moment that things like the Xbox 360 controllers are becoming harder and harder to find. The USB dongles, particularly the good ones, the Microsoft ones, are harder and harder to find. The USB shields have become, you know, it's harder to get decent ones. So, you know, it does. I think we do probably need a replacement at some point for the old pad ones. And these ESP ones are, you know, incredibly powerful. But the other thing is, of course, that they can control servos, they can manage the interrupts, they can output to what we want to output. So they've got a lot less limitations than some of the other microcontrollers. So it's quite exciting to play. I know a few people played around with the Xbox One when that came out, but what Microsoft is, they use their own proprietary Bluetooth on that, so it became harder to get something that works with the Arduino. I don't know whether PS4 have gone down that route or whether they've kept more of a standard.
it seems to be because there's just a basic wait statement, and you attach the MAC address for the Bluetooth. It doesn't have the proprietary header that the Microsoft stuff does. But yeah, I mean, the physical size, right? Whereas we would try to cram, like, I know I crammed an Uno into one of the micros because because just why not? Tim Taylor, that son of a bitch. But this physical size now limitation, the requirement to not have a whole separate stack of boards, the ability to tap from an existing, like you said, up to 10 volts, but you don't want to for servos and whatnot. So yeah, I'm toying around with that a little bit, and I mean, I wouldn't say I'm down for rewriting Padawan 360, but I think it has, honestly, I think it could do it a lot better. I think it can, and there's some simple breakout boards. I posted one on Facebook if anybody wants to look. I think, well, on the thread we were talking about, a really nice breakout board for the ESP32. So yeah, I'm pretty excited about it.
Yeah, I've got a few breakout boards coming, because that'll just get through that red panel, that breadboard that I've got it on at the moment. And what you've got then effectively is one breakout board, and you can control anything really. 7, 8, 9, 10 servos, sound counter.
I'm even thinking, actually, I think the first project I was kind of looking at was the dome control, right? For all the panels and everything, because whereas now you're stacking a bunch of, the Mega and a couple of things, I think you could get it all done and have it be a little bit cleaner with an ESP32.
Oh, definitely. The other thing that's kind of been a problem with the nanos and stuff is trying to get servo smoothing. So running servos at different speed other than the max speed that they are by default, which does involve microprocessing power, because what you've got to do is do acceleration and deceleration, and that's where you kind of hit problems with the Arduino capabilities and power. Whereas I think the ESP probably do some nice servo smoothing as well. I mean, the Maestro is probably a good hardware solution for it, but I can certainly see, like you said, a lot of things like that just kind of taking up really. Sorry, Anne.
When you say the breakout board, would that be the thing you would connect the ESP32 when you put it inside your robot? Because
Yes.
I just looked at this because I'm familiar with the breadboard or the whatever that's called, but you can't use that inside.
Yeah, I'll grab it from the thread and I'll just post it in a chat. But that's exactly it, right? It's basically a simple way for you to have screw terminal attachment
Got
to
it.
all of this stuff.
No,
Now, I'm a
that's
personal.
exactly-
If anybody, I don't know if anybody has messed with ferrules, but I use them a lot. They're a crimp-on style connector that instead of twisting a wire and putting it into a screw terminal, it basically covers it up with a tin, with a metal connector, and it square pinches it. It square crimps it, and that creates really solid connections. And you don't have to worry about individual like little strands of the copper coming out and weird kind of stuff like that.
I think that's I mean, that's what when we put these little boards together for the now, that's effectively what it is. All you've really got is you plug your board in, and then one of the things that you really want is power distribution. So with here you've got lots of power distribution. You've got your control pins, and then you've got a single power in with a regulator that converts the power. And the breakout boards are pretty much like that really. The advantage with the ESP is that you don't need much more than a breakout board because of the capabilities of the damn thing, So, and you don't have to connect things like Bluetooth because they're already on there. So it is really quite exciting, as Sean said.
Yeah, that second link is the one. It's just one that I've come across that is one of the nicer boards, a little bit cleaner, a little bit, nicely labeled. And the ability. Part of the reason why I reference this board is I'm a little OCD when it comes to labeling things, so I will print out custom label bars for things, and this having a designated space already there for custom labels and codes and whatnot. But yeah, this is kind of where I see making kind of the next generation of controllers, just from the sheer CPU performance and capabilities. And as it sits, something like 90-something% of the Arduino libraries are already compatible. And a lot of times when you get into, like when porting around even between different Arduino devices, it's just with some of this stuff, a lot of the code will work fine, swapping out a library and changing some pins. It's that straightforward.
Yeah. So that's the breakout board that you put the link for, isn't it? Yeah, there's
and I'll paste the link to the ferrules too, just because it's just something I've been in the habit of using for a very long time. I think there's some crazy kit at Amazon that my kids got me one year.
Okay, thanks, Sean. Any more questions?
Yeah, I've got a quick question. When I look up on Amazon, I see different variations of the ESP32. I see an ESP32S and an ESP32 CAM. What's the differences? What are we going for? Is it just strictly ESP32?
The ESP32 is the main core chip, and then the ones that I got were dev boards. Now the pinouts, whereas your Arduino seem to have standard pinouts, and again, anybody who knows better just jump in. But there doesn't seem to be the same standards on the ESP32s. But all I think it means is that you just have to choose, make sure that you choose the relevant pins for your particular ESP32. Capabilities are still the same. There's also memory differences. I think the ones that I've got are 4 meg. It will support up to 16 meg. So you can get different variants with different memories, but effectively the core capabilities and the core way of it working is the same, really.
The one with CAM is a camera module for the ESP32.
Okay.
Just to let you know.
Gotcha. Okay. Thank you.
So you can actually plug a camera into them as well. So
That's cool.
yeah,
that's cool.
I mean, I know a lot of you guys probably know that I'm fairly invested, shall we say, in the Padawan system. I'm incredibly excited about the ESP32 myself. I've just bought 3 of them to start playing with, and they're going to be a game changer. I think, in my personal, just like Padawan was a game changer, as Michael said, I think ESP32 is going to be another it's another level again. It's like all things in life. There's these quantum leaps from time to time in technology, and at the price point that you can get hold of these things, I bought 3 of these for £9. Which is what, $14 or something. I bought 3 of them from China, and they came down within about 10 days. Phenomenal, absolutely phenomenal.
Yeah. So I think, to even add on to that, Steve, I think, I just linked one there as a talking point, and just talking about the capabilities of the ESP32. So if you imagine this one that's linked here with a simple OLED display embedded, still with all the features, 8 megs, and the higher clock cycles. So that, because, there's always that scare, don't modify the Padawan code too much or else you're going to create a weirdness. So now we're going to have these higher clock cycles. Oh, and I have this OLED display. So let me see what's going on. I hit a button. Now I'm actuating my joysticks or my controls, and it will tell me on this display, easy enough to code, everything that's happening. This is huge. Like Steve said, I'm crazy excited about the capabilities of this controller.
Oh, it is. It's amazing. I mean, there's a library for Alexa. You can connect these things to your Wi-Fi. I was playing around with it before, actually. You connect it to your Wi-Fi, and then it simulates one of the standard Alexa libraries. So you can get the commands to it from Alexa by switching lights on, switching lights off. So the versatility on it is incredible.
So I can only imagine, once this gets mature, someone on in your group, Michael, will be, Alexa, how charged is my R2? Alexa, et cetera. And you could know all those kinds of things.
We're renaming Alexa to R2 and just doing direct voice commands.
Yeah, that's what I was thinking. That's cool.
Well, I didn't talk about the other things with the ESP, but it's got built-in touch sensors, so it can capacitance touch sensors, whatever they are, where you touch the metal and it knows you're touching it. That's built into those things.
Just to show you how fast all this stuff is moving, literally about a week ago, I sent Michael a link to a capacitive touch control board. It's got 8 separate inputs for capacitive, because I was so excited about it. And now this thing just does it out of the box, does it on the chip for less than half the price of what I paid just for the capacitive system.
It's also got a Hall effects
and Hall effects as well.
So you can detect magnets when magnets come near it, and
I know that the processor is more capable. What does it say? It's a 240 megahertz on average. I don't know how that compares. I know because the platform is different. Obviously, the system architecture. I don't know how the cycles compare across to a mega or something. That would be the only thing that probably.
But the Mega's still 8-bit, isn't it?
Yeah.
Well, it's still 8-bit.
And super processor.
And it's a single core. So the SP is dual core. It's 32-bit and it's 160 megahertz.
Yeah. It's
So-
600. Wow. Yeah, blah blah blah. Yeah. I mean, I think in the RAM is 520K is what it says. 8 megs of flash on that one I linked. Yeah. Anyways, I'm sorry. We could fanboy about this for a bit. I'm really excited.
Sean's
about
completely
Fabric.
fanboying out.
But,
Guys,
Close it around, isn't it?
guys, I have a question. When you were talking about Padawan 360, you were recommending Mega because it has 3 usable serials to communicate with motor drivers.
Yeah.
I read about this thing, ESP32, that it has just 2. Can we somehow use the software to go around it, or how do you think this will be resolved?
Software serial, I would think.
yeah, I mean, I've got an idea. If anybody, so what I was thinking, understanding the 2 serial port limit, honestly, is one, because they're so inexpensive and small, one would just be dedicated to driving those motors. Like you'd have a foot drive, and over serial you would just communicate from ESP32 to 32 saying do this. You would send the commands out. When it's doing direct drive from all 3 serial inputs for one device, you would just have 2. I mean, that's kind of the way that I was mentally mapping it out.
It does say there's 3 serial ports on the SP32.
Yes, but one is used for communication. It's shared for USB.
Yeah. So I mean, you've also got things like the I2C bus on there, which is another alternative way of communicating, or as we said, software serial. So even, I mean, you can run Padwans on Unos, and we use software serial for those as well. So I don't think it's a showstopper really.
Yeah.
Okay. In this case, it is also possible to use ESP32 in conjunction with older ESPs. They do not have Bluetooth, but they are much more cheaper. And I think with serials, they are at the same level. So basically the cheaper price inside the Droid, you can have another ESP without Bluetooth capability, whatever. But that can actually deal with the motors and the other stuff if this is the way.
Yeah.
Frankly, for the price of less than a pint of beer for a brand new ESP32, it's almost a moot point, Stefan. For £3 per device, whereas maybe £2 for the one without the Bluetooth, it's almost not worth even thinking about.
Can you daisy chain them? Sorry.
Maybe not from the point of money, but from the point, I don't know. I'm not familiar with hardware. I have software background, but I don't know how much electricity can it suck if it has Bluetooth attached, or that is something to be measured. That's my only concern, not the money wise.
Right. So to look at it from this perspective, though, too, is the traditional Padawan is powering the USB device, and your power output, your power consumption on that USB transmitter for the Xbox is going to be higher than the Bluetooth is. Just in sheer, I mean, that's just how it is. So the power draw on the Xbox wireless receiver over USB is actually more than you're going to get on the Bluetooth. So you're better off going that route anyway. So there's a lot of trade-offs, quote unquote, but I don't think they're trade-offs. I just think it's all about flexibility and extensibility. And like with the software serial bus, it's like this is I'll get really cheesy for a second. This is the way. This is it.
Yeah.
I think. Well, I mean, the thing is,
everyone else is the way.
Well, and now that you've uploaded, I know you have, you started putting the Arduino code up there. I might get brave enough to throw up some of the ESP drone control stuff that I'm working on. unfortunately, we're not drinking today. Maybe if I had 4 or 5 more drinks, then I'd definitely be brave enough. But we'll see.
But see, I mean, when we spoke to Dan on the pad one, I mean, Dan literally took the stuff that they were developing on the Shadow and just kind of ported the Xbox controller on there. So the pad one code itself could easily then just all you really try and do is find a way of inputting the controls. So there's a quick way of doing it. Somebody wanted to just have a little bit of play around with it.
Yeah, I think the only one that I haven't, I don't have the controllers, the large motor controllers. I don't know if that library is compatible on the ESP.
What for the Sabertooth?
Yeah.
Yeah, that's well. Dimension Engineering who do Sabertooth are incredible from support perspective, and I think it uses standard serial comms, so it's more of whether there's a library available to it. But I imagine as it gets more popular, I can't see any reason why they wouldn't do that.
Yeah, that was exactly it. I don't know if the library is compatible, but
yeah,
I may find out soon enough. So we'll see.
It's exciting. Anyway, I think if we've not got any more questions, I think we've covered off pretty much what we wanted to cover off. Massive thanks again for everybody who pops along to these things. I will record them. I'll stick them up on YouTube because I know they're really useful to everybody else as well, just to kind of get their head around them. So thanks for popping along.
I've not so much got a question. I've got a bit of a problem.
Okay.
I've got all the ESP. I've downloaded the libraries. I know that I can connect it. I got it connected to the computer eventually. After I found out the original USB cable I was using is purely power, and it didn't have a bloody signal line on it.
Yeah.
So after swapping cables, I managed to upload the ESP Wi-Fi search code to it, and then in serial monitor I could see it. It was giving me sort of like local Wi-Fi networks to connect to. So I know that I'm able to talk to the board. I've opened the Blink ESP32 diff steering code. Gone to verify it before I've done anything. The only thing that I have changed is the authority code for Blink to my particular app. And when I verify it, I get an error message up with regards to the servo library and compatibility. Now, if I
the reason for that is that I'm using another servo library that I downloaded. I'll put a link in with the code. The default serial library is default for Arduino, not for ESP. So I found another one that I used.
Yeah, because how do I? Oh, this is. Have I shared that screen correctly?
Yes.
Yeah, that's what I'm getting. It's saying that it's just not. The library supports boards with AVR, SAM, SAMD, NRF, etc. But that's not happy with the ESP.
Yeah, that's because I'm using. Let me have a look to find it. I'm using a ESP32 servo library, which I need to find.
Right, yeah, because I see that obviously in your code you've got it labeled up as servo.h. I have got I think I've got the ESP, that one, ESP32 servo.
It's called Servo ESP32, the one that I've used.
Right, okie dokie. I will have a look for that in a moment.
Yeah, I've just in my rush to play around with it, I just downloaded the first one that I found, and it's called Servo ESP32. There's 3 examples that come through it. I'm just looking to see if there's any. There's not a lot of documentation actually on those. It doesn't give me the links to which one that is, but if you just Google ESP32 servo, you'll find it.
Yeah, and then would it just be a case of where here it says servo.h, changing that to that particular library?
Well, once you've installed that library, that code will then load.
Radio.
It's because
Okay.
the library's not installed.
Yep, radio. No, that all makes sense. It was after Droids and Drink last night, and I was just, yeah, it took me a while to get the board talking to my computer, and then not being able to get it to compile, and I was starting to pull my hair out.
Yeah, no,
But,
it's I've used a third-party one. But if you just have a Google for that, you find it. I'll hunt the link and stick it up anyway.
Yep, no worries. That's brilliant. Cool.
All right, folks.
Thank you.
Thanks again. I will have to go and disappear now and cook some things to eat, I think. But great session. As I said, we'll record it and get it out there. And hopefully I'll see you all soon on Drinks and Droids or on another one of these sessions. So take care.
Brilliant.
Thank you,
Cheers,
Michael.
guys.
Of course.
Thanks very much.
Thanks,
Cheers.
everyone. Take
Bye,
care.
bye, bye.